All right, the second part of this, now we're going to get into some experimental details. All right, so the way that this experiment is going to work is that we are going to give you a sample with 4 phthalates in it. Not every group is going to have the same phthalates. Everybody is going to have a different mix. We're going to give you the identities of those compounds, though. So you're going to get a vol flask like this. And for example, you might have dimethyl, diampentyl, dipropyl, and bis-2-butoxyethyl phthalate. Again, this is just an example. These might not be the compounds that are present in your unknown. And based on what you have in your unknown, you're going to then generate some multi-component standards. So you're going to make a multi-component stock solution containing all 4 of these compounds at a concentration that allows you to create your calibration curves. You're going to create 2 calibration curves. You're going to create the external calibration curve that you guys should be very familiar with at this point. We're not using internal or surrogate standards in this experiment, so don't worry about that. This is just a straightforward external calibration curve. And then we're going to be doing a standard addition measurement as well. I'll get to that in a second here. So once you've created those calibration solutions, you're going to use them to develop your GCFID method. So you're going to take one of those calibration solutions and you're going to run it multiple times on the GCFID, changing the method slightly each time until you get good separation of your phthalates. And then once you've got that optimized method, you're going to use it to run the rest of your samples and identify and quantify all of the concentrations of phthalates in your unknown sample. And finally, we're going to use some of those quality control samples that we've been using all semester to validate this method. So are you getting good recovery? Are you getting any matrix effects? Do you have a low MDL? Is there any blank contamination? We're going to check for all of those things to validate this method. All right, so what are we going to require of you in terms of making this GCFID method and then in terms of the quality of your calibration? So the first 4 requirements here have to do with the GCFID method. First of all, we want to achieve baseline separation. So all of the peaks should come back down to baseline before the start of the next peak. You only have 5 minutes to achieve this. So all of your analytes must come off of the column within 5 minutes, and they all must be baseline separated. To protect the GC column, we want you to start at 100 degrees C minimum. You can go higher than that if you want, but you cannot go higher than 300 degrees C or we will start to degrade the stationary phase on the column. Once you've got your calibration curves, we want to see an R squared greater than 0.98. And we want your, you have to perform both the external and standard addition calibrations. All right, so given those requirements, where should you start? Well, we are going to provide you with an isothermal method to start. So we're going to have a method set up. You can start with that and see how that works out for you. But then what are you going to want to do if that doesn't work out? And I can tell you right now, it's not going to work out. So you should be prepared to move on to something a little more complex. So the question here is, what properties are used to separate compounds by GC? And you guys should have some familiarity with this by now. So take a second to think about that. And hopefully the first thing that pops into your mind is, we're ramping the temperature here. We're separating the compounds based on their boiling point, right? When they go into the gas phase and start traveling through the column. The other property that should be, that is relevant here is polarity. So that stationary phase on the capillary column is going to, or compounds are going to interact with that stationary phase based on their polarity or their affinity for that stationary phase. We're not going to be changing out the columns here. to change the polarity of the stationary phase. So what sort of instrumental parameters do you think that you can play around with then? Well, we can't mess around with the polarity of the separation. So instead, you're going to be able to play around with the temperature. So really all we're asking you to do here is to come up with an oven temperature program that allows for the separation of these 4 phthalates. All right, so like I said, you've got 5 minutes to do this. So let's look at some example chromatograms here from previous semesters. So starting with that isothermal method, you might run into a situation like this, where you get 1 peak. You're supposed to have 4 peaks for 4 compounds. Where are the rest of the peaks? Well, maybe only 1 peak eluded within that 5-minute time period because your starting temperature was too low. So in the next run, maybe you bump that starting temperature up. And now you've got possibly 1, 2, 3, 4, 5, 6, 7 peaks. You're supposed to have 4. Where did those extra 3 peaks come from? Well, they might be the 3 peaks that didn't come off in the run before, and they're left over and carried over into this run. So what I recommend is that if you have a situation like this where not all 4 peaks elute in that 5-minute time window, that you you basically clean the column, bake the column out in between samples. So just turn the temperature up to 300 degrees for 5 minutes and then run your next sample. Another thing you'll notice on these chromatograms is they don't stop at 5 minutes. It's totally okay to run your samples out for 6, 7 minutes when you're developing the method, just so that you can see when these compounds elute and try and develop a better temperature profile going forward. All right, so in the end, what we want to see is a chromatogram like this, where you've got all 4 peaks baseline separated. You can see this bis2 butoxyethyl peak here comes all the way down to baseline before the start of the diisopropyl peak. So that's what we want to see in the end. And I'm sure that you will all be able to achieve this. All right, so you're going to have a solution with 4 phthalates in there. We'll tell you which phthalates they are, but how do you know which peak corresponds to which phthalate? And if you recall back to our we had a similar issue with the last experiment that we did that had multiple analytes. And that was the ion chromatography experiment where we're looking at different cations. So what did you have to do in that experiment? You had to make single component standards. So when you're preparing for this experiment, you should prepare some single component standards of 4 phthalates that you are assigned so that you can identify them in your beautiful looking chromatograms.